Welcome, dear students. Today we'll talk about positions of a point and a straight line and a circle with respect to a circle. This is for grade 9 second term. In this slide we'll talk about position of a point with respect to a circle. Here we will have a point and a circle. If M circle with radius length R and A is a point on the circle plane, then we can see here A is outside the circle. Now we can say that A is outside the circle. So that means the length of MA will be more than the length of the radius R. If R 5, then MA here will equal 6 centimeters. If MA equals 7, R equals 6, and so on. Now, if we have another circle M, and this point, as we can see here, it's on the circle. A is on the circle. In this situation, the length of MA equals the length of the radius. If the radius equals 5, then MA also equals 5. If R equals 7 centimeters, then the length of MA equals the same length. In this situation, A become inside the circle. A is inside the circle. In this situation, we'll find the length of MA less than the length of the radius. If the radius equals 7, then the length of MA will be less than 7. It may be 6, maybe 5, maybe 4, maybe 3. Now in the second situation, position of a straight line with respect to a circle. Now we will have a straight line and a circle. If M circle with radius length of R and L is a straight line on its plane, MA perpendicular L, perpendicular here, this reason we put it to write the measure of length of MA. The length of MA, as we can see here, we have the straight line L and the circle M. The straight line L is located outside the circle M. The straight line L outside the circle. So the intersection between the straight line L and the circle M equal phi, no intersecting point. In this situation, the length of MA, this line segment, is greater than the radius R. The radius for this circle, of course. In the second situation here, this straight line L become closer to the circle. It cut the circle or touch it only at one point, which we will name it A. The straight line L is tangent to circle M. Here we have this word tangent. It's an important word. We will use it in many situations. L intersects the circle equal A. Here we have only one point of intersection. So MA equal R. The length of MA equals the length of the radius R. Here the straight line become closer. It cuts the circle at 2 points C and D. The straight line L is a secant. Now we will name it secant to the circle M. And L intersects circle M equal 2 points, the point C and the point D. In this situation, MA, the length of MA will be smaller than the length of the radius. The radius, if it will be 5, MA smaller than 5. MA may be 3.5, it may be 2 centimeter, 1 centimeter, and so on. Now we will have important fact. This fact said that a tangent to a circle is perpendicular to the radius at its point of tangency. This is the point of tangency as we can see here. This is straight line perpendicular to this line MA, which is a radius in this circle. And here also, if a straight line is perpendicular to a diameter of a circle at one of its endpoints, then it's tangent to the circle. If we have a diameter AB and you have a straight line perpendicular to this diameter from its endpoint, that means this straight line will be a tangent to this circle. Now think, how many tangents can be drawn to a circle M? First, from a point on the circle, we have point A on the circle. How many tangents we can draw? We can draw only one tangent. If we have a point outside the circle at the point A here, as we can see, we draw two tangents to this circle. The first one is this line and the second one is this line. What is the relation between the two drawn tangents to the circle from the two endpoints of any diameter on it? If we have a circle and you have a diameter AB and you have a tangent, that means it's perpendicular to the diameter, and you have a straight line L2 also is a tangent and it's also perpendicular to the diameter. Now what is the relation between L1 and L2? They are parallel. The straight line L1 parallel to the straight line L2. Third position of a circle with respect to another circle. Here we have many situations. Notice that MN is a line of centers and is the axis of symmetry for both circles. Here we have two circles, the circle M and the circle N. The radius of the first circle M is R1 and the radius of the second circle N is R2. And we put a small description here that R1 greater than R2. The radius of the first circle M is greater than the radius of the second circle M. If Mn greater than R1 plus R2, then M intersect N equal phi. The intersection point between the first circle M and the second circle N is 0, no intersecting point. That means M intersect N equal phi. The surface of circle M intersect the surface of the circle N also equal phi. And we can name this circles, they are distant, and the two circles are distant. In this situation, the circle N become closer to the circle M. In this situation, we can see that they are intersect at one point here. We will name it A. If Mn, the length of Mn, the line between the first center and the second center, equal exactly the length of R1 plus R2, then M intersect N equal A, this point A, and the surface of the circle M intersects the surface of the circle N equal also A. And the two circles are touching externally. We will complete here. Here the circle N intersect the circle M in 2 points A and B. If R1 minus R2 less than Mn, and Mn less than R1 plus R2. That means the length of Mn between the difference between the two radii and the summation of two radii. Then M intersect N equal A and B. We have now 2 points of intersection, and the surface of the circle M intersect the surface of circle N equal the surface of the yellow area. Here we have this area. We will color it in yellow. This area, which is in yellow, is the intersecting area. Now we have the circle N inside the circle M. The circle N, the smaller one, inside the circle M, the greater one. If Mn equal the difference between the first radius R1 and the second radius R2, then the intersection between the two circles is this point, which we name it A. And the surface of the circle M intersects the surface of the circle N equal the circle N, the smaller circle. And the two circles are touching, but here internally, not externally. In this slide we can see that the circle N become inside the circle M. In this situation, the length of Mn less than the length of the difference between the two radii. Mn less than R1 minus R2, and then M intersect N equal phi, and the surface of the circle M intersects the surface of the circle N equal the circle N itself, and the two circles are intersecting as in the figure. No intersecting point between the circles, but we have intersection between the surface of the circle M and the surface of the circle N. And when we shade it, this is the point, this is the intersection area, which is in yellow. Here we have a special case when Mn equals 0. That means M is on the point N. They are the same point. Then the two circles are concentric. That means they have the same center as in the figure. Thank you and goodbye.